Hey guys, this is me again. I wanted to take the next step in the study of vectors as we're nearing the end of this. Um, we know by now vectors have a magnitude and direction. They have to have both. We also know that vectors can be expressed in component form, which takes the vector and puts it on the coordinate plane and talks about the movement on the coordinate plane. So today what I want to do is look at going from one format to the other format. So going from component form to magnitude and direction, but also going from magnitude and direction back to component. Okay? And I want to do that by looking at the example that we have in the worksheet. The example starts out with the vector -5, 3. That means that vector would go backwards 5 and up 3. So the movement would be this way and that way, so that our vector would look like that. It would go backwards 5 and go up 3. So in order to find our magnitude, what we have to do for the magnitude is we have to look at the square root of -5 squared plus 3 squared comes from the Pythagorean theorem, which equals the square root of 25 plus 9, which is the square root of 34. So that is the magnitude. Okay? And then for the direction we said was the tangent inverse, because it's a triangle, of y over x, so 3 over 5. Since the tangent inverse of 3 over 5 is, well, that's right there. Let's clear this and type it in again. This again is the Desmos.com scientific calculator. Tangent inverse of 3 divided by 5. Enter is 30.96 degrees. So that's 30.96 degrees. Now, that is not our direction, however. Remember, since this is our triangle, the 30.96 degrees is this angle, 30.96. And our direction, the direction that we're looking for, is from 0, so it's this way. Well, that would be 180 minus 30.96, because that's the reference angle. And I'm not going to try to do that in my head. I'm going to go 180 minus 30.96. And I'm going to get 149.04 degrees. So the direction is 149.04 degrees. So in magnitude and direction form, -5, 3 would be the square root of 34 at 149.04 degrees. That is the same. Those two are the same vectors. They describe the same movement. Now, the worksheet that we have, however, asks us to put the direction not only in direction angle form, but we want to put it both in as a bearing and as a map bearing. So let's draw that angle again. Our angle is 149.04 degrees. We also know, based on our work from before, that this angle is 30.96. And we know that the bearing starts from the vertical. So the bearing starts here and goes all the way around until it reaches the vector. So this is the bearing. So the bearing starts at 0, goes to 90, 180, 270, and then it goes 30.96 more. So the bearing is 270 plus 30.96, which equals 300.96. That is our bearing. Okay. Then let's look at a map bearing for that. So looking at the same figure, the map, if you recall the map is looking at north, south, east, and west. So this would be south, this would be north, this would be east, and this would be west. And I really, because the angle is in the second quadrant, I really only want to focus on that part right there. That's all I want to look at. So I know I'm looking at, for map bearing, I'm looking at west and I'm looking at north. Right? And I have a vector that goes this way with an angle here of, well, we know this one. Let's go to the other one first. This angle is 30.96. And the total angle is 90 degrees. So to get the other angle, we would go to our calculator and do 90 minus 30.96. And that gives us 59.04. So this angle here is, draw black, 59.04. So our map bearings would either be, if you have 59.04, that is going in the west direction, starting at north. If you have 30.96, let's do that one in red. That is going in the north direction, starting at west. So that's 30.96 degrees north of west, or 59.04 degrees west of north. So those are our map bearings. Well, this is what we did last week. Okay? What we haven't done is we haven't gone the other way. Okay? So I know that it's square root of 34 at 149.04 degrees. So let's write that. If I'm starting in magnitude and direction form, my magnitude is the square root of 34. My direction is 149.04 degrees. Okay. We know from our unit circle, the biggest thing that we have to remember, if you remember when I said back in September, we'd be using the unit circle all the way through the year. One of the biggest things we have to remember from the unit circle is that the cosine refers to the x and the sine refers to the y on the unit circle. The only thing that's changed now, because we still have a vector going in a direction angle, the only thing that's changed is the hypotenuse, or is the length of that vector. So to change from magnitude and direction form to component form, you just have to do a very simple calculation. Your components would be the magnitude, which is the square root of 34, times, for x, the cosine of the angle, and for y, it would be the magnitude times the sine of the angle. And let's see what that is. Let's go back to our calculator. it is the square root of 34 times the cosine of 149.04 and the square root of 34 times the sine of 149.04, and the cosine is negative 5.0, and the sine is 2.999, which rounds to 3, so that would be negative 5 and 3, and that is where we started. The components are negative 5 and 3, which is exactly what we started with. So that's how you change from magnitude and direction to component form, okay? And from component form to magnitude and direction. And so that's what we're asking you to do on this particular worksheet. If you would complete it and upload it to Teams, life would be grand. Thank you very much.